Welcome. In this video I'm going to show how you can determine the alternative ratio, also known as a relative risk, as an effect size measure for a binomial test using R. I'm using Jupyter Notebook together with R, so the code you can simply copy paste in any R IDE if you want. I'm just used, so for example, RStudio, and you should be able to follow this then along. The exact version of R I'm using is version 3.6.1. I'm going to be showing the alternative ratio, sometimes known as relative risk. This is one of the possible effect size measures for a one-sample binomial test. I haven't found much information about it. In one document it's called alternative ratio from a program called PASS. And on Stack Overflow I found someone calling it relative risk. If you have some more information, please let me know in the comments below. The example I'm using comes from a SPSS data file, so I'll load that into my R. I get some warnings, but that's okay, and I'm going to use as a binary variable in this data set, gender was set to binary, so I'm going to use that as my variable. Then, just to get a quick impression, I create a small table of my variable, and I noticed there were 12 females and 34 males, so about almost 3 times as many males than females. The proportions can be quickly calculated by just dividing by the sum, and so it's 26% versus 74%. The alternative ratio itself is the proportion divided by an expected proportion. So since I only have 2 categories, then I would say that most often I would probably suspect that it would have been 50-50, so my expected proportion would have been 0.5. I'll store that separately as P0, and then I can determine my alternative ratio by simply dividing the observed proportion by that expected proportion. In this case, for the females, that's 0.52. So this means a 1, if you look at the formula, a 1 would have meant that it's exactly 0.5. And this is 1 minus 0.52 would be 48% below the expected. If we would have done it for the males, it would have been the exact opposite. Simply divide that expected, the observed property by the expected one, and you might notice this is 48, 0.478 something. Above 1, so it's 48% again above the expected proportion. So the females were 48% below and the males were 48% above. So I would report the alternative ratio as being 48%. Now, unfortunately, I've also not been able to find any rules of thumb to indicate if this is large or not. I would consider it quite big in this case, but that's just me, but I haven't found any source to give me some official or semi-official rules of thumb. So if you do have those, let me know. And that's it. That's how you can quickly calculate the alternative ratio. There are other effect size measures, that perhaps are more suitable. You can check out my website peterstatistics.com to see more about those. Alright, thank you for watching and I hope this was helpful.